So hello students, basically in this PPT, in this particular recording, what I am going to explain you is about first software testing. What exactly is software testing? So again, this topic was already covered in the class, but since some of you were having difficulty in this topic and this topic is also important for your end semester exams, I will be explaining some of the crucial topics uh, in this again. Also, I will be going through the sample end semester paper that I have already sent it to you. In the sample paper, there were some of the important topics like the cyclomatic complexity, software cost estimation. Those also I will be discussing in this particular recording. So make sure you watch it till the end. Okay. So first, let's discuss about software testing. So software testing, as you all know, we have already discussed, it is the process of executing a program. It is the process where you test your code, whether it is executing fine or not, whether it is having some errors or not. So as we discussed the entire software development life cycle, so we started from the requirement phase, then the implementation phase, and before that the designing phase, then we did the coding and finally the testing phase. So all those phases we have already looked: the requirement engineering phase, the designing phase, the implementation phase or the coding phase, and eventually the testing phase now. So now here you are supposed to test your software. Now, when it comes to software testing, there are different ways, different testing techniques through which you can test your software. Again, software is not a small thing. It is a huge entity, okay, having multiple artifacts to test. So that's why in according to that, the testing is also divided. So we have different types of testing under the software testing part. So one is the manual testing again, and next is the automation testing. So again, under the manual testing, we need to explicitly prepare our cases manually. Okay, so manually you are required to prepare your test cases. You yourself will be preparing the test cases, and this also will be seeing how you will be making the test cases. So in under the manual testing, we have the black box, white box, gray box testing, and further under the black box we have functional testing, the non-functional testing. Again, as we have already discussed, what is functional, what do you mean by functional testing? You could recall this from the functional requirements and non-functional requirements which we have studied in the previous lectures, that the functional requirements or the functional testing is related to the testing part of the entire functionality of the software, whereas the non-functional part or the non-functional requirements which you could recall were related to the those requirements or those things which are good enough to have in a software, but they are not mandatory. Functional requirements were the one that are actually mandatory, because these are the set of requirements that the customer want in their software. Okay, they won't be accepting your software without that. Whereas non-functional requirement, such as we have, let's suppose the loading time, the screen loading time is very less, the response rate is high. All those comes under the non-functional requirements, which are good enough to have. Based on that, only we have functional and non-functional testing. So we'll be looking into each of these testing. So first type is the unit testing. So unit testing, again, unit testing, as the name itself implies, it tests the smallest unit or the smallest part of your software. So while, again, if I explain you in terms of code, so let's say, if you could recall, we made a Java project. Under the Java project, we first create some packages. Inside the packages, we have, again, let me just write, we create a project. Let's say I create a Java project. Under that, I'll make different packages. Under the packages, I will have different class, let's say class 1, class 2, and so on. Under the classes, we might have multiple method. Let's say I have method 1, I have method 2, and so on and so forth for different classes. Now, if you see here, the smallest unit here is, let's say, a method. Okay, so maybe smallest unit here, what I want to test is a method. So this is a unit here. So let me just test each method in my software. Okay, so these individual methods are the individual units of your software. So this could be an example of unit testing where we are again testing individual units. Okay, and then later on what we do, we then move to the class part. Let's say now I will test one first class one. Under this class one, the method, the individual methods are already tested. Okay, so this was the same bottom to up approach, top to down approach, which we have also discussed in the previous lectures. So this is an example of unit testing. Method 1, method 2, 3, 4. We are uh, testing an individual method inside the class. Next is an integration testing. So again, as you move up, as I'm moving up, I'm integrating the parts and moving up, right? I'm integrating the different methods which are giving me a class. Then different classes are integrated and they're giving me a package. So I'm integrating them. And as I integrate them, I test them. So again, now next step is I'm testing my different classes. So I'm integrating the method, testing the different classes. They come under the category of integration testing. How I am integrating it and testing it. And again, after let's say testing the different classes, I will be moving on and I will be testing the different packages which I have. So that's how we move from bottom to up in the integration testing part. Okay, so this is an integration testing. And next is the regression testing. So regression testing focuses on what happens if you add a new module in your software. Like let's say if I add any new method here. If let's say I again add any other method here, so maybe I add, let's say method 5 here. So what will happen if I add this method here? How will this class behave? And how will the rest of the class behaves? Okay, if rest of the class has dependency, any dependency on this class, how will they react? How will they behave? So that is done with the help of regression testing. They make sure that the whole code is working fine, even if you add a smallest component or a smallest module. Okay, that is regression testing. Next is the alpha testing. So alpha testing is a type of acceptance testing. So this testing is done before the product is released to the customer. So basically, when the product is ready, when the software is ready, first they are test in the environment of the testers, in the environment of the development team, especially by the QA people. So QA people they test the software within the organization to see whether everything is working fine or not, or if there is any error. So the testing here is occurring in a familiar environment, okay, under the supervision of the QA people or the developers. Whereas beta testing, the different variant of this testing, is something which is tested in the real time environment. So when I talk about real time environment, it means this is the environment uh, that is completely controlled by the client. So we are running the software in the client environment. So till this point, under the beta testing, the software is already released or given to the end users. Okay, and they are the one who are actually using the software. So we are building the software for the end users for whom we are working. We have delivered those software. We have delivered the software to them, and now they are using the software. So now the software here is getting tested in the real time. How it is behaving in the real time. So here, no supervision of the QA people or let's say the developers are here. The software here is working under the, you can say, under the in the actual environment. So this is the beta testing. So these two are the different variants. So students generally get confused between the alpha testing and the beta testing. So this is one that is under the supervision of the QA people. And the second one, this is there where the software is run in the real time environment. Next is the system testing. So system testing is, uh, as the name itself implies, here we are testing the entire system. So here you need to test your complete system. So when you are testing your uh, entire system, so there you want to test by including the functional as well as non-functional testing, means the entire thing. Software is nothing but the combination of again the functional requirements and the non-functional requirements. So based on those, we design our software, and then we test the software according to those two things which are defined as functional testing and non-functional testing. So here entire software is tested, okay, but this comes under the black box techniques. So black box means that you are not caring what is there inside the software. So black box means you don't know what is inside the box. You only know there is a box in front of you. What exactly is happening inside the box that you don't know. So black box testing means you don't know what exactly or how exactly the things are happening inside the code. You are only interested in giving the input and getting the correct output from this black box. Okay, so some input is given and you only want correct output. As soon as you are getting the correct output, you are assuming that everything inside this black box is working fine. So this is black box testing. So system testing comes under the black box testing, which does not focuses on the internal working of the software, and they are only concerned with what inputs you give to the system and what output you get. Next is the stress testing. So stress testing, again, as the name itself implies, that you are giving the software your code, you are giving it stress. So stress means you are giving it unfavorable condition, or you are making it run under the unfavorable condition. What unfavorable condition it could be? Maybe maximum memory is getting utilized, maybe there's thrashing, maybe excessive disk requirement it is asking for. So under various unfavorable conditions, you check how this your software is working. So that is an example of stress testing. You are giving a lot of stress to your piece of code, and you are seeing how it is reacting to that stress. So that comes under the stress testing. Now, next is again the various testing that we have just discussed. They come under the two broad categories of testing, which are defined as the black box testing and the white box testing, which we have just shown in this graph. Again, now what exactly is are these two testing? So black box testing is a testing, as we have just discussed, it is focused only on what exactly is the external design of the software, and they do not care about the structure, or let's say the implementation, or how exactly the system is being run. So black box means internal details. We are not concerned of that. We are only concerned of what is the external output there. On the other hand, white box testing is completely opposite of the black box testing. White box testing says that we do care of what exactly is happening inside the software, how exactly the code is, uh, you can say, behaving inside that. So we definitely want how many lines of code we have written, what exactly, how much complex is your code. Okay, so all those things, the cyclomatic complexity that we are discussing there, all those comes under the white box testing, because we are scrutinizing the code. What exactly is happening? We are scrutinizing each and every line of code. So that comes under the technique of white box testing. So these are the two broad categories of testing. Under these categories, we have different sub testing categories, different types of testing. So black box means you're not cared of what are the internal details. White box means you definitely care how the internal details are there in the software, and you test those things. So these are the points related to the black box and white box testing. Again, inside the black box, the implementation of code is not needed. Here, the code implementation is necessary. They are black box since the implementation of code is not needed, so they can be mostly done by the software testers. Here, the code implementation is necessary, so they are mostly done by the software developers who are developing the code, because here you need to have a knowledge of implementation, and here no knowledge of implementation is required. You are only caring of what output you are getting. As long as you are getting correct output, you are good to go. So this again relates to the functional testing. What is the functionality? Input, output, is the functionality matching? Great. Otherwise, this thing, white box testing, it is related to the structural part, means how exactly is the structure of your code or what exactly you have written. So these are some of the you can say differences between the black box, white box testing. Here, logic testing is there, white box. So obviously, code is written, logic testing is there. Here, behavior testing is there. So these differences you can again just have a look. So these are the different types. So under black box, I might have functional testing, I might have non-functional testing, I might have regression testing. In all these three types of testing, I do not care what exactly is written inside the code. I am only care of what output I am getting. Whereas in the white box testing, I have three kind of testing, which says path testing, loop testing, and condition testing. In all the three types of testing, we definitely care what exactly is happening inside our code or how exactly our code is behaving. So they are the example of white box testing. So under the black box testing, the first testing which is important is the equivalence partitioning. So what exactly is equivalence partitioning is? So this particular type of testing, it divides my input into certain domain. Okay, into a certain range, it divides my input and then I derive my test cases based on them. So based on these domain of input, I derive my test cases. So they define, let's say from 1 to 100, the input can belong to 1 to 100. So this is the domain that they have defined. And then based on this domain, I will define my test cases. So, and the test cases which I define, I need to find whether the test cases belong to the equivalence class, means whether they belong to this domain or not. So this just let's first look at the example, then probably it will be more clear. So let's say I have an example here which says that here there's a text box here where you need to define how many pizza you want to order, and the values it can have is only 1 to 10, means at a time you can only order maximum 10 pizza from 1 to 10. Values from 11 to 99 are considered as invalid, and the error message will be popped up that only 10 pizzas are ordered. So in this case, you can define that the valid input here is 1 to 10 only. The rest, everything is considered invalid, be it a 3-digit number, okay, be it 0 numbers that are less than 1, they are considered as again not required, they are considered as invalid. Numbers greater than 10, again they are considered as invalid, they are not no longer required. So this is a equivalence class that you have defined, that okay, whatever that falls inside the class is correct, otherwise the program will give an error message. Okay, next, so as you can define, again they have defined the different partitions. So they are partitioning based on the input. So the domain is 1 to 10. Okay, based on 1 to 10, what they are doing, they are partitioning it. So see, they are partitioning it. So again, less than 1 is invalid, greater than 10, again they are invalid. Okay, so what they do, what the testers do, let's say any number uh, which falls between 1 to 10. Okay, as you can see here, maybe number 5. Okay, let's say if I have a number 5, any they take any value from this test, from this set, and then they test your software. So now you can see we have, let's say, multiple values. We have one value that says less than 1, one value is 1 to 10, one value is greater than 11, and less than and equal to 99. Okay, and next is greater than 99. So we have all these different values or different set that we have defined here. Now what a tester will do, now tester will say, okay, value less than 1 is one case, so let me test first it with maybe, let's say, -1. Okay, it will give an output as invalid. Now, they will only check with one such value like -1. They will not check with, let's say, -2, -3, -4, or any other value, because they know for every value they will get the same output, that is invalid. So what they are doing, they are only selecting one value from the partitioning. So again, they have selected -1. Next, maybe between 1 to 10, they will select one value. So let's say they have selected 5. So for 5, it is giving you a valid output. Okay, so maybe that is correct. Third, third is this partition, let's say. Okay, so maybe between 11 to 99, they have selected 88 as the number. So they will test at 88, whether at 88 you are getting invalid or valid. So obviously at 88, you will get invalid. Okay, so fourth, greater than 99. So let's say I test at 121. So 121, again I got value invalid. So you don't need to check at each and every number. Let's say -2, -3, -4, -1, 0, 1, 2, 3, 4, 5, 6, and again 11, 12, 13, 14 till 99. No, you don't have to check for each and every number. You only need to select one number from this subset and test your software for that number. That is the advantage of using this equivalence partition or the equivalence classes. Okay, you are only testing your software from one particular value. Okay, that is there from the set, from the partition. Rest you don't care. So again, let's say if I talk about third example. So in an example, let's say the question says in an examination, a candidate has to score minimum 24 marks in order to clear the exam, and the maximum mark that he can score is 40. So we have the range 24 to 40 defined here. Okay, where I'm including 24 and I am including 40. So 24 and 40 are included. So what you need to identify, you need to identify valid equivalence values if the student clears the exam. So what could be the valid equivalence values? So valid equivalence values means the value should lie in this range. So any value out of these three, out of these four, any of the three values which you feel are lying in this subset are considered as valid. So let's say I take the first example. So first example has values 22, 23 and 26. So 22 is definitely out of this domain. So that means this particular option is wrong. Next, I have 21, 39, 40. 21 is again not following in this range. This option is wrong. Next, 29, 30, 31. 29, 30, 31, each of them are following in this particular range. That means this particular option is correct. And fourth, 0, 15, 22. Here you can see 0 and 15, they are not following in this range. So definitely this option is also wrong. And ultimately, I am just left with this third option, which is correct. Okay, so that's how you are identifying the valid equivalence values. Here, all the three numbers are lying in this set, in this domain that is defined. Now, let's say the question comes that give an example of input values that cover all the equivalence partitions. So again, we have defined here, if you see here, we have three classes that were defined because we have 24 to 40 range in the question. So we might define three classes. First class is values that are less than 24. Second could be values that are between 24 to 40. And third is values that are greater than 40. And obviously only the second case will be valid. Rest two will be invalid. Again invalid. So it says that identify or give an example of input values that cover all of the equivalent partitions. So this all is important here. So all means we have three partitions here. So you need to give an example where all these three values are considered. So what I can do is I can pick one value from here. So that says value should be less than 24. So let's say any number less than 24, maybe I just pick 20. Okay, here 24 to 40, maybe let's say I pick 30 here, and greater than 40. So maybe let's say here I pick 50. So here these three cases 20, 30 and 50, they are belonging, they are covering all these three equivalence classes, right? So therefore this particular option you can say is an example of valid, or you can say is an example of input values that cover all of the equivalence partitions. So any value from the option which you say that any value out of so here 20, 30, 50 are covering each of this 1, 2 and 3. So therefore they are the example that you can say they are covering covering all the equivalence partitions. So you need to figure out or find the value that covers each of these three equivalence partitions. This is an example of the input values that cover all of the equivalence partitions. Now next is an example of boundary value analysis. So this is the second technique here. So boundary value analysis is a test case design technique to test the boundary value between the partitions. So what exactly this boundary value says, that a boundary value is an input or output value of the on the border of an equivalence partition, which includes minimum and maximum values at inside and outside boundaries. So that means now what what exactly this boundary value means. Boundary value says that let's just check the software for the inputs that are lying in the boundary, that are lying under the boundary. So under the boundary means, let's say, boundary values which are, so let's say if I have a number from 1 to 100, okay, so maybe maximum error that I can have is under this boundary condition, maybe from 1 to maybe 100. So let's say I will test my value from, let's say, here 1 is there, so maybe I test my value, let's say, for 0, maybe I can test for 1, maybe I can test for 2. So these 0 and 2 are the values that are under the boundaries. And this one here 100, maybe here I can, let's say, test my you can say software for value like 99, maybe for 100, maybe for 101. So I'm testing under the boundaries, right? You can see I'm testing my software under the boundaries here. So the boundary value testing says how you need to test your software. You need to test your software under these five things. So what these five things are: value that are minimum, that is the minimum; value that is just above the minimum, so value that is just above the minimum; a nominal or a mid-range value, again just below the maximum; and finally the maximum value. So now let's see one example of this boundary value analysis. So this is a question that says, given a day in format of day, month, year, you need to find the next date for the given date. So you need to perform the boundary value analysis for this. So these are the conditions that are given: day, month, and year. Okay, and what you need to do is you need to find the next given date. So the output should be the next given date. Now first you see here what we have three conditions defined here. We have date, month and year defined. So I have the date, I have the month, and I have the year here defined. Okay, so date belongs to, let's say, 1 to 31 is the date. Month is between 1 to 12, and year is between 1800 to 24. So these things are already given to me in the question. So they have defined the domain, they have defined the domain range to me. Okay, this is the domain range for me. And what I need to do is I need to perform the boundary value analysis for this. So under the boundary value analysis, when this thing is written in the question, what you need to do is you need to prepare the test cases based on the boundary value testing. So what first, now as I say that you need to prepare the test cases, first question is how many number of test cases do you need to prepare? Okay, how many test cases you need? So the formula here to calculate the number of test cases is this, that is 4n plus 1, where n is your number of input variables. So let's say here in this case I have three input variable: day, month, year. So here I have three input variables that are defined. So n value is 3 years. So my test case will be 4 into 3 plus 1. So that will be 13. So that means in this question I need to prepare 13 test cases for these conditions that are given. Now, how you will prepare the test cases? Now, these are the test cases that are written. Now, if you see here, if you see previously, day was having the domain as 1 to 31. Month was between 1 to 12, and year was from, let me check, 1800 to 2048. So month, yes. So this is the, you can say, domain, or this is the uh, domain that is written here. Okay, the range. So day can vary between 1 to 31, month 1 to 12, and year 1800 to 2048. These things will be given in the question. And since there are three inputs, you have already calculated that the number of test cases that are required are 13. So what you have to do here is, first, as I said, and again, just recall that boundary value test cases test the software in these five things, means minimum value, just above minimum, nominal, just below maximum, and maximum. So that means, let's say if I have day here, okay, that is defined from 1 to 31. So according to this logic, what will be my minimum value? My minimum value here is 1. ठीक है, value just above the minimum is 2. Then nominal value means the middle value. So between 1 to 31, let's say I take 15 as minimal value. Okay, and then value just above the maximum. So above the maximum, first, what is maximum? Maximum value is 30. Okay, so value not just above, value just below the maximum. So you can see value below the maximum. So value below the maximum is 29 here. So value below the maximum is, let's say, 20. So okay, maximum value, sorry, my bad, 31. Let me just correct it. Let me just erase all those things. Yes. So again, the maximum value here is 31. Okay, and value just below the maximum is 30. So 1, 2, 15, 30, 31. According to this criteria, I have all the value for the day. Okay, for this day variable. Next, for the month variable, if you see, for the month variable, the domain is 1 to 12. Again, minimum value is 1. Value above the minimum is 2. Maximum value is 12. Value just below the maximum is 11. And midway, let's say 6 is the value. Again, for year, we do the same thing. Okay, for year, what we do? The minimum value 1800, value just above is 1801, maximum is this, value below the maximum is this, and mid value. So mid value, let's say here could be, they have taken 2000. Let's say take 2000 here as the middle value. Okay, so again, all the criteria, all the five things have been already defined for each of the input variable. What you need to do is, now you need to prepare a table having test ID as the first column. Test ID will go from 1 to 13. Why? Because we had 13 test cases. As you can see here, we have 13 test cases. So it goes from 1 to 13. Next will be day. So day value can be 1 to 15, 30 and 31. So we have already seen it could be 1 to 15, 30, 31. So that have written 1 to 15, 30, 31. So they are written here. Now next what you do is, under the month and year column, okay, for each of these 1 to 15, 30, 31, you will have the nominal or the mid value for each of these two columns. So the nominal value for month was 6 and the nominal value for year was 2000. So you have 6 here listed and you have 2000 here listed. Okay, then next you switch to these five are completed. Now from here, what you do is you start changing the value now of month column. Okay, now month is 1 to 11, 12. 6 was also there, but if you write 6 here and let's say 15 and 2000 will already be there, so you can see this particular row will be same as this particular row. So that's why they have omitted it. They are not using it. So you can skip this thing. You can skip this value. Okay, so this value can be skipped. And after 1 to 11, 12, you write in the month column, you will write the nominal value for day and month, that is 15 and 2000. So these were the nominal value for the day and year. Now, next, after these are 9 test cases are completed, repeat the same thing for year. Year can range for 1800, 1801, 2047, 2048. Okay, and the mid value will be here. So mid value for day was 15, mid value for month was 6. So those things are again repeated here, 15, 15 and 16, 16. And the expected output. So expected output as mentioned in the question will be the next date based on the given date. So next date again. So now just let me erase everything. So as you can see here, the next date or the expected output here should be the next date. So let's say if the date is 1, month is 6 and the year is 2000. Okay, so what would be the next date? The next date will be 2/6/2000. So that is the expected output that is written here 2/6/2000. Similarly, if date is 2/6/2000, what would be the next date? That would be 3/6/2000. Okay, so that's how you will be writing the expected output. And one thing, if you see this particular combination, this says 31/6/2000. So 31/6 stands for June. Okay, so but in June there is no 31st. June month is still 30th only. There are 30 days only. So this means this particular combination is invalid. So here the output will be invalid. So you need to check whether the date combination here is first valid or not. If valid, then you need to write the next date. Otherwise, you need to write the invalid date as the output. So these are your complete boundary value analysis. So in exam, if the question comes, you need to prepare such test cases. Let's say 13, 14, how many number of whatever number of test cases are there. You need to prepare these test cases in the exam in your exam. Similarly, we have the next question here. So next question says that we have three sides of a triangle A, B, C. Three sides of the triangle are given and all three sides can range between, can take value 1 to 100. So all three can take value again 1 to 100. So since all three can take value 1 to 100, okay, what are could be the minimum value? All will have 1 as the minimum value, 2 as the next value above the max minimum. Nominal value, mid value will be 50, then 49, so and then sorry 99 and then 100. So these particular five combination will be repeated for A, B and C, both the three uh, you can say input variables, and the number of test cases here will be same. Again 4n plus 1 was the formula. N again here is 3 because we have 3 inputs. So 4 into 3 plus 1, again 13 test cases are there. Okay, so you can see the 13 test cases are listed here. Okay, and again A, B, C are there. So we have value 1, 2, 99, 100 and 15. Okay, for first, and for rest everywhere else I have the nominal value that is 50. Next B column I have 1, 2, 99, 50. For each of these two I have nominal value defined, and similarly 1, 2, 99, 60, and then for these two I have nominal value defined. And now the output here is the question says that the function should output the type of triangle, whether it is scalar, isosceles, equilateral or not a triangle. So for not a triangle, you could recall that a triangle is formed, or you can say it's a valid triangle if the sum of two sides is always greater than the third side. So you need to check if in any of the test cases this particular condition is not satisfied that the sum of the two side sum of, let's say, side 1 and side 2 should always be greater than third side. If in any of the test cases this condition is not satisfied, then that means that particular output is invalid, or you can say not a triangle. So let's say if I take first example, which says 150-50. So you consider any two side. Maybe I consider 50 and A and B here. 50 plus 1, 51 is always greater than 50. Again, 50 plus 50, 100 is greater than 1. So condition is satisfied. And you can see type of triangle here is isosceles because two sides are same. B and C both have 50-50 value. So whenever two sides are same, we have isosceles. Whenever all the three sides are different, we have scalene. And whenever all the three sides are same, we have equilateral triangle. So you can say majority output is isosceles only. Here you can see output is equilateral because all three sides are same. Now, not a triangle is this 3, 4, T4, because you can see here sum of two sides. Let's say I take 50 and 50. So 50 plus 50, that is this B plus C, is not greater than third side, which is 100. So because here 50 plus 50, 100 is equal to 100, it is not greater. Okay, so this condition is void. That's why the output here is not a triangle. Similarly for this case, similarly for this case. So this is an example of your boundary value analysis. Okay, so in exam, if the question comes, you need to follow this approach and you need to design the test cases here. Now, now this was completely about the software testing PPT. Now let me just share. Let me just share the entire screen. Second, let me first share the question paper. So yes, this was the sample question paper, which I gave it to you. So this is the sample question paper. Okay, so you can see the answers there. So first says which of the following is not managed by the tech side in developing the software. So the answer here is cost, because obviously the tech side means the developers, the entire your team there, they do not manage the cost, because cost is something that you can say the client, they tells you, or they suggest you, or they give you the cost. So costing is something which is not under the hand of the tech side, the developer side. Which of the following is limitation of waterfall model? So waterfall model limitation is all of these. Requirement should be known. It is difficult to understand and use. Bad model for inexperienced staff. So the answer here is all of these. In the V model, the verification phase is also known as, so this is pretty straightforward. It is known as the developer's life cycle. Which software model can be used if the system is partially implemented before or during the analysis phase, allowing the customers to see the product early in the life cycle? So obviously early in the life cycle, so you need prototype partially implemented. So again, you give the prototype to the customer, they see it, they make some changes, then again you make the changes in the prototype and the cycle goes on. In agile-based development, which of the agile principle recognizes and exploits the skills of the development team? So the answer here is people, not process, because obviously agile based development focuses more on the people-oriented approach rather than focuses on the previously defined processes and the traditional process that are being followed. It focuses more or give more importance to the people that are there in the team. And which is not an example of refactoring? Again, answer there is none of these, because all are the example of refactoring. So in refactoring, you need to reorganize your code to remove the duplicates, you need to rename your variable, you need to replace the inline code with calls to methods. So all these are the example of refactoring. Next question says that the spiral model is one of the most important software development lifecycle model which support risk handling. Describe how this model helps in identifying and resolving risk. So here the again what you need to tell is under the uh, spiral model, the lecture 4 which I have given to you, which discusses about the spiral model. There you need to tell that the diagram which we just which I've just explained in the class, the spiral model diagram, which says that there are 4 objectives under the spiral model. You need to uh, determine the objectives, identify alternative solution, then you need to identify and resolve the risk. You need to develop next version of the product, review and plan for the next phase. So this is under the lecture 4th. Okay, under lecture 4, probably slide number 12. So there you can find out the answer for this side. So you need to just explain what exactly is the spiral model. Obviously, the prominent example or the prominent, you can say, advantage of spiral model is risk handling only. So it was specially developed to manage risk at the software. So you can see how you can explain how the risk is managed under the spiral model. Extreme programming is one of the best known and widely used agile method. Identify and explain 2 extreme programming practices that help you to develop the fast software. So 2 extreme programming practices, again, that is there in lecture number 5, which I have given to you. Under that, you can see under the agile software development, you can see there will be one slide which talks about extreme programming practices. Okay, so there is one particular slide which is completely devoted to extreme programming practices. Okay, so there you can find multiple extreme programming practices like refactoring is one, small releases is another, test first development is another, incremental planning is another. So you can explain any of these 2 practices. Now, coupling measures the degree of interdependence between the model. Explain why content coupling is the worst form of coupling and how you can redesign it. So again, you need to revisit the content coupling slide lecture 8, and there I have explained that content coupling is bad. Why? Because content coupling modifies the data that is internal to any component. So let's say I have 2 components defined. Okay, in one component I have variable A, in next component I have variable B. So the variable B component can also modify the component of variable A. So that is wrong. Whatever you can say methods or whatever variables are there under one particular component should not you can say uh, those variables can only be accessed by the members of that component. The different you can say different components should not you can say hamper or should not alter the behavior of that component. So the content coupling is bad because the let's say if 2 components are there, so each one component can obviously alter the methods or obviously alter the values of the next component. Okay, so that is wrong, that should not be there. And how you can reduce it? So we can reduce it by following the encapsulation principle that is there in the object oriented world. So you declare your methods, you declare your variables as private under the class. So here the concept of object oriented programming and making class comes into the picture. Under class, we defined the you can say methods, the variables as private and methods as public. So this thing was also explained in the class. So if you don't know, you can again refer to the lecture 8 PPT. There you will get the answer that you need to define the methods as you need to define the variables as private and methods as public. Only the method of that class can access the variables of the next class of the same class. No other external component can change the variable. So that was the example. Now section B talks about, first you are given some piece of code. You need to find the control flow graph and the cyclometric complexity by using all the 3 methods in detail. So again, let me just quickly explain the cyclometric complexity also. And this question is obviously very important, the cyclometric complexity. So let me just quickly explain what exactly is cyclometric complexity. So as you can see here in this piece of code, so Again, some piece of code is given to you. You need to first draw the control flow graph, which is the CFG of the code. So control flow graph, again, so let's say if I have this following piece of code, how will I draw a control flow graph of it? Now as you can see here, they are line number 1 2 3 4 5 6 7. Okay, so what I need to do, the control flow graph, it tells me what is the exact flow of this particular program, how this program is behaving. That is depicted by this particular control flow graph. So you can see here that the first line says that if A equal to 354, then B is greater than C. So first I'll just write 1 here. So 1 denotes A equal to 354. Sorry, if A equal to 354. So this line is denoted by this 1. Okay. And you see, as soon as if the next thing is, then do what? So if is a conditional statement, obviously. So under if you have, so if something is there, okay, then if this is true, then you have some piece of code. Otherwise, you have other piece of code that are there. So if this is correct, so you execute this, otherwise you execute this. So obviously it will have two flows here, 1 and 2. So if A is equal to 354, okay, if this is true, then obviously second line will be executed. That is this. So I have written here second here. Okay, otherwise, so now if this go wrongs, so the its end part will be executed. Now how do you find the end part? So first what you can do is you can again rewrite this code as, let's say I write first if A equal to 354. Okay, then what you do, you put some space and write then, second one, then again some if is started, if B greater than C, third, then so for this if the next then, so this then will be of this immediate if and not this. This you need to remember. So there here it is written then A equal to B. Okay, so if this second B is true, then this, otherwise fourth this, else do what? Else A is equal to C. And under the fifth part, fifth says that you need to end this if, and sixth says you need to end the if, and seven says parent A. Now what you need to do is, now let's say I have, you can see here that this if scope is from this to this, because obvious, and this if score is from this to this. So first you need to figure out the innermost the scope of the innermost if statement. So this innermost if statement, obviously it is starting here, so obviously first the innermost if statement will execute. That's why this end if is belonging to this. So once this particular section of code execute, then only you can come out and execute the external, this particular if block. So that's why I have rewritten this particular piece of code, so that it is more better for you to understand. So let's say I have this if, and this is again end if. So if this is true, so again if this is true, then you go to the next line. Otherwise you simply come out and go to the sixth line. That's why you can see here this line is there, sixth. So otherwise you can, again let me just erase it. Okay, so again, so first if A equal to 354, if this is correct, you go to the second statement. Otherwise you simply go to a sixth statement, that is here. You simply go here. Okay, then second, now second is again a if statement. So again two things will be there. As soon as you have an if statement, you know that a condition will be there, two things will be there. So if this is true, then the third line is executed. So you go here and simply write 3. Okay, so then this is there. Otherwise, if this becomes false, then this else will be executing. So this complete block belongs to the innermost if. So again, if this is wrong, you go to the fourth part that is there, and this is the fourth part here. Okay, now both the thing. again, if this part execute, then you reach 5, and if this part execute, then also you reach 5, because now you are ending the if statement. So both the thing will eventually come here. Okay. And after that, after the innermost if is executed, you then go to the outermost if, that is the sixth part. So this is how, that's how I'm connecting to the sixth part. And then last is the seventh, so which says print A. Okay, so this is the entire flow. The control flow graph is the entire flow of your software, how exactly your code, line of code is behaving. So this is the cyclomatic complexity. Now there are three methods that are used to calculate the cyclomatic complexity. So first you need to draw this control flow graph. Then you need to find the cyclomatic complexity using all the three methods. And obviously all the three methods will give you the same result. So thereby you can see that you can validate whether the control flow graph you have made correct or wrong. If the control flow graph is wrong, then either of any of these three method will give some other value. So you can thereby see, you can thereby come to know that okay, there is some problem in the control flow graph. So first method first says that the cyclomatic complexity is equal to number of closed regions plus 1. So number of closed region you can see here in my particular graph. Let's say this is the control flow graph. So the closed region is one this. So this is the first closed region here. So this is first. Okay, second closed region is this. Closed region means there is no scope of getting out. So this is the second closed region. Okay, so there are two closed region only. So two closed region are there. So the number of closed region here are 2. Okay, plus 1 will give me 3 here. Now the second method says that the cyclomatic complexity is equal to E minus N plus 2. So E stands for edges, N stands for nodes. So edges are the arrows that are there. Let me again remove everything. So edges are the arrows, okay, and that are there in the control flow graph, and nodes are your the circles or the nodes that are there from 1 to 7. So edges are the arrow, means this is one edge, one arrow, okay, one. This is second, 2. This is 3. This is 4, 5, 6, 7, 8. So we have total 8 arrows, means 8 edges. Nodes are these. The one, we have one node, 2, 3, 4, 5, 6, 7. So we have 7 nodes here. So the formula is edges minus nodes plus 2. That means 8 minus 7 plus 2. Answer here is 3 again. And third method says cyclomatic complexity is equal to P plus 1. So P stands for number of decision nodes. Okay, so number of decision nodes. So so how many decision nodes are there? So you can see here that the number of decision node is this first. This is a decision node because you have two decision, either go here or either go here. So this is the first decision node. This is the second decision node because again you have two decisions to be made. Okay, then this is not a decision node, not a decision node, not a decision node, and not a decision node. So again we have just two decision node. So that is 2 plus 1, again 3 is the answer. So we have 3 as the cyclomatic complexity here. And so these are, so on the similar lines, you have problem 2 also. And so you can solve this problem 2. So this problem 2, if you see, and the same problem is there in the sample paper also that I have shown you. So how to calculate the cyclomatic complexity of this? First, you draw the control flow graph. So you can see here one, again, first is just the declaration. So you will write here 1. Okay, next float z. So again float z. So 2 here is defined. So after seeing this statement, compiler goes to this statement, and then third is also there. Input 3y. Okay. Then next fourth is if statement. So again, if this is true, then compiler goes here. Otherwise, the compiler goes 6. So from 4, I will have two path, 5 and 6 here. Okay, and both will again eventually after running the statement, the compiler goes to 7th statement. So both will meet at line number 7. Okay, so after, if only the first statement, if there is no bracket written, only the first statement comes under the if, under this block. Okay, else this thing is executed, and when if is finished, you come to line number 7. Then from 7 you go to 8. Okay, 8 is a while loop. So while loop is a loop which continues running until this condition is false. So as soon as you enter the while loop, you will run line number 9 also, line number 10 also. Okay, and from line number 10 you will again move to line number 8, because this is while loop, it keeps on running. Okay, so again you move to line number 8, then you move again from 8, you again move to 9, you again move to 10, and then again you move to line number 8. And as soon as this condition is not satisfied, or this condition is wrong, you come out of the while loop from here to here. Okay, so here the while loop is ending, you can see the arrow. So here the while loop is ending, so you will come at this point. So in the same way, the same thing is depicted in the control flow graph. 8, 9, 10. Okay, similar thing, and from 10 you will again go to the while loop, and when this loop, this condition is false, then you come to the 11th node. Okay, 11th node is again a decision node. If this is true, then go to line number 12. So from 11 you go to 12. Okay, then from 12, okay, if this condition is false, then you go to line number 13. So again from 11 you can see 13 also. Okay, so and again same thing. So if thing is here, if y is greater than 0 is there under this. Okay, if that is true, if this is true, so this is executed. Otherwise, if this is false, then this arrow is executed, and eventually you meet at the 13 statement, and 14 is the end. So this is the complete control flow graph. So it is nothing but it is just telling you the how exactly your program or your entire code is running. So you should know how exactly an if loop and a while loop runs. Okay, the if and while loop, the logic of these two loop must be clear to you. Then only you can make these diagrams, otherwise you will be confused. And finally, the question says that calculate the cyclometric complexity using all the three methods. So again, the same thing is there. You need to again calculate the number of closed regions, calculate the edges, nodes, and the number of decision nodes, and compute the cyclometric complexity. So that is about the cyclometric complexity question. Now again, if I revisit the sample paper, so this particular cyclometric complexity code that is already done, and next questions talks about calculate the uh, software cost. So the again calculated the software cost, 400 KLOC project size is given, and the project schedule is not very tight, and you need to calculate the effort, development time, average staff size, and project productivity. So for this, let me just open the slide which talks about the software cost estimation. So there is the slide. So this is an example of software cost estimation. So there, this I've already explained in class, and you have done your lab assignment 9 also based on that. Okay, so on the similar lines you need to solve. So the answer is given here. Okay, this is the answer for the question that is given. Okay, so but in the question, it says that the project schedule is not very tight. So for that, you need to first see which model you need to find, organic, semi-detached, or embedded. So again, organic, semi-detached, embedded. So you need to see what all three methods are there. So we have, as I've already discussed, organic method. What is this organic method? then semi-detached, then embedded. So all the three methods are being already discussed. You have done your lab assignment 9 also based on this particular question. So I'm assuming you people are aware of all the three methods here. And so again, based on that, there are formulas that are given. So these are the formulas here: effort, time, person required. Okay, you need to just put the value here 400. Select A, B, C, D value based on the type of model that is there. Okay, so project schedule is, let's say, not very tight. So maybe semi-detached is the model here. So for that, you need to learn first. Please learn this table. Okay, and A, B, C, D should have these values. Put these values and you will get the answer. So this is the complete answer, this particular thing. So 400, you put the value and don't forget to write the unit also, person month here. So that's how you calculate it. And again, if productivity and average staff size is given, so you know what is the formula of productivity, of average staff size, and of productivity. So this also you know. So that's how you will be writing or answering that particular question. And now next thing, if almost there on the question paper. Now next is the, in an examination a candidate has to score minimum 30 and the maximum marks is 50. Identify the valid equivalence value. So again here you need to just write down the valid equivalence values. So that could be again any number between 30 to 50 is a valid equivalence value. Okay, so this thing only you need to write it. Any number between 30 to 50, maybe 32, 33, 35, 37, 40, 45 are the valid equivalence value. So that is only the answer for this particular question here. Now section C talks about uh, these two things. Question 1 and question 2 says class diagram. Question 2 says activity diagram, and question 3 here it says sequence diagram. So again, all the three diagrams have been explained in the class. Okay, you can refer any online resource here. Okay, to see what exactly is to just have a basic intuition about the diagrams. Rest everything is already mentioned in the question. You need to know the notations of class diagram, activity diagram, and sequence diagram. Okay, prepare well. All the three diagrams should be prepared well. Make sure you know all the notations, and based on that, what is there in the question. So already, let's say it is already telling that you have professor, a class name professor, class name student. Okay, maybe again read the question and find out what could be the different classes here, what could be the attributes here. You can see attributes are already mentioned here for some of the classes. So you need to just figure that out. So practice the class diagram, activity diagram, and sequence diagram. Also the activity diagram needs to be created using swim lanes. So this also we have done in the lab assignment. These swim lanes, make sure you use swim lanes while making the activity diagram. So this was all about the different topics that I wanted to cover for your end semester exam. So these were the some of the topics where you were facing difficulty, or some of the important topics were also there. Make sure you study the sample paper well, okay, and the important topics also which I've mentioned. Okay, so that's it. So thank you everyone.